Hey folks, just want to give you a quick little video on how you can go and use our awareness of gravity and therefore the acceleration of gravity to go and calculate both speed and distance over time. And so this worksheet here, I'm just going to focus on the first part of this worksheet, and with the knowledge that I'm about to help you kind of really reconcile and figure out, you should be able to answer all the questions on this worksheet. So make sure you take the time to read this top paragraph here. The big takeaway is that when we talk about the acceleration of gravity, we're going to talk about the acceleration of gravity always being 10 meters per second. So 10 meters per second, or sometimes it's also written 10 meters per second squared. That's called an acceleration. Okay. Now I'm talking about the word acceleration, which means change in speed, whether you're speeding up, slowing down, or changing direction. We should also identify this idea of speed. And so if you could, on your paper, you're going to notice there that I do give you some definitions here at the bottom, but if you could also draw a triangle like this. Oh gosh, my poor pencil here. And let's see, put an S there, a D here, and a T here. And the way this works is this means division, and this means multiplication down here. Okay, so speed is distance divided by time, which is kind of an easy way to remember. Every time you see a speedometer sign on the highway, they're always telling you miles per hour. Miles being a distance, hour being the time, and the word per meaning in math a division. So miles divided by time per hour, if you will. All right, so listen, here's the deal. We've got this person who's dropping a rock off the cliff right here, and on the rock is both the speedometer, which tells you how fast it's falling, and an odometer, which tells you the distance traveled. And so we need to kind of keep that mindset going here, because each one of these markings here, time equals 0, time equals 1, time equals 2, 3, 4, 5, and 6, all the way down the paper. That's what we're going to use to calculate what is the speed as well as what is the distance traveled. So you'll notice there that the first one's kind of been done for you, and that's plenty good, plenty fine. Let me give a little zoom in here. All right, so here we go. At time 0, everyone should notice that the speedometer is set to 0 and the distance traveled is 0, because it's literally just being let go. So it hasn't traveled any distance. That makes sense. But at time equals 1 second, this rock has been able to fall for 1 second. Now remember, what's the acceleration of gravity? Based upon the paragraph that you read, it's 9.8, but we're rounding that to 10 to keep our math nice and simple. So at the end of 1 second, how fast should this rock be going? Well, we already have an arrow showing. It's going 10 meters per second. And that makes sense. To go from 0 to 10 took 1 second. Now, with that being said, you'll also notice down at time equals 2, we have another arrow pointing to the 20. And that makes sense because every second we're adding another 10 meters per second, because that's what the acceleration is. So we're going to go from 0 meters per second to 10 meters per second to 20 meters per second. Any guess what's going to be the speed of this rock at the end of 3 seconds? All right, you're right. You got it. It's going to be 30. So could you please draw an arrow to the 30 at the 3 second mark, just like that you see on the screen. So draw an arrow to the 30. All right. Now, without any kind of like major patterns being developed here, I'm pretty sure you guys could calculate what's the time at, the speed at 4 seconds, 5 seconds, and 6 seconds going down your paper here. But there's one more aspect to this speedometer, odometer that we need to address, and that is the distance traveled. And this one does involve a little bit of math, but I'm pretty sure you all are up to the task for this. So here's what I'd love for you to do. You'll notice there, at time equals 0, we had a speed of 0. At time equals 1, we had a speed of 10 meters per second. Now, most of you are familiar with averages, but everyone should probably have this rationale that the rock didn't literally go and be instantaneously 10 meters per second at the end of 1 second. It had to speed up. And so for speeding up from 0 meters per second to 10 meters per second, we need to find the average speed between those two speeds. Well, can anyone help me out? What's 10 plus 0 divided by 2? Because we have an initial speed, we have a final speed of 10. 10 plus 0 is 10. Divided by 2 would be 5. Oh, check that out. And you'll notice here, when calculating distance, Distance is equal to speed times time. Well, if the average speed was 5 meters per second, then the time was 1, so 5 times 1 is 5. And that's why we've written in here 5 meters as distance traveled. Okay? All right, so that covers that, but I think we need to do one more session here for the 2 second, because I need you to understand that the distance traveled is going to be cumulative. So we're going to keep adding as we go. So let's look at the next one. So time equals 2 seconds. We know it's going to go 20 meters per second. At the beginning of before the 2 seconds, so like to go from the 1 to 2, the speed was 10, and now the speed is up to 20. So what's the average between 10 and 20? You got it, class. That's 15. How did I do that? I added 10 plus 20 to get 30, and then I divided by 2. So speed was 20 plus 10, 30, divided by 2 is 15. So now I know that if I go and have an average speed of 15 meters per second, and it's going to go 15 meters per second on average for 1 second, that distance traveled is going to be 15 times 1, or 15. But how far have we already gone? That's where the 5 meters comes into play. So what's 5 plus 15? You got it, class. 20. Could you please write 20 into the odometer right there? Again, that's 20 into the odometer right there. So we've gone 0 meters per second, 10 meters per second, 20 meters per second, and our distance has gone from 0 to 5, and then in this next second we went 15 meters per second. That was the average speed, but we'd already gone 5, so 15 plus 5 is 20. See if you can't go and figure out the distance traveled for the next set of seconds. Also, you want to make sure you answer the questions over here, and then there's more questions to occur on the back side of all these worksheets. All right? Good luck, folks. We'll talk to you in class. Take care.